When fuels are burning or combusting, they yield light, heat, gases, and smoke, the products of combustion. When a fire is burning in the open, the products of combustion are readily released into the atmosphere. On the other hand, when a fire is burning inside a structure, the products of combustion may be trapped. Heavy accumulations of confined combustion products can create a life-threatening atmosphere for firefighters who may have to enter a structure for search and rescue of victims and fire suppression. The fire service has devised techniques and recommended procedures for releasing dangerous accumulations of heat, gases, and smoke through a process called ventilation. In this program, we will define ventilation, explain the need for ventilation, describe types of ventilation, explain factors affecting ventilation, and demonstrate basic ventilation procedures. The ventilation process may be as easy as opening a door or window, or as complicated as chopping a hole in a roof. In either case, the desired result is the venting off of confined heat, gases, and smoke. Ventilation can then be defined as a carefully planned release of the products of combustion from a confined area or structure. Ventilation, like other specialized firefighting techniques, can be used to realize certain benefits. Properly planned and executed, ventilation can release confined combustion products to the atmosphere, reduce the danger of entering a burning structure, and assist in the control of a fire. Improperly planned and executed, ventilation can intensify a fire, promote fire spread, endanger personnel, and create unnecessary property damage, which can result in poor public relations. To understand the need for ventilation, look what's taking place inside a burning structure as the fuels burn or combust. The combustion process generates light, heat, gases, and smoke. Intense heat is generated, which can accumulate at upper levels of a room or structure, often exceeding 1300 degrees. Inhaling superheated air can be fatal. Toxic gases may be generated. In addition to carbon monoxide and carbon dioxide, there are literally hundreds of toxic and non-toxic gases which may be generated depending upon the fuel involved. Many of these gases have both short and long-term effects on those who inhale them. Dense smoke contains other combustion products which were not completely oxidized. In addition, smoke contains carbon, soot, and dust. Inhaling smoke can severely damage the respiratory system. Ventilation releases these dangerous accumulations of combustion products, acting as a chimney to vent off heat, gases, and smoke. Depending upon the type of structure, certain conditions may develop which set the stage for a backdraft explosion. When a fire has been burning for some time in a confined area, it uses up most of the available oxygen. In this third phase of burning, the area is heavily charged with combustion products. Free burning has stopped. The atmosphere is starved for oxygen. Backdraft is an explosion which occurs when oxygen is suddenly admitted to an oxygen-starved atmosphere. Warning signs of a potential backdraft explosion includes the puffing of smoke out from around doors, windows, and under eaves, and the surprising lack of flames. If a door or window were suddenly opened into this atmosphere, the inrushing oxygen causes an immediate explosion of fire into the free burning phase. Properly planned and executed ventilation at the top of the fire will gradually admit oxygen to the fire, reducing the danger of creating a backdraft explosion when the structure is entered. Through a process known as convection, cooler air rushes in to replace the vented combustion products, dispersing smoke, which improves visibility, and cooling the interior, which reduces the danger to firefighters who may have to enter the structure. The fire will spread from one fuel to another and from one area to another through direct flame contact, convection, radiation, and conduction. Ventilation can slow the spread of flames by drawing the fire to the vent hole and providing a chimney through which the combustion products can escape. This has the effect of slowing the spread of fire, assisting in the control and suppression of fire. We've demonstrated the conditions which may require the ventilation of a fire to facilitate the release of heavy accumulations of combustion products. There are three types of ventilation: vertical, horizontal, and forced. Vertical ventilation is accomplished by creating a hole immediately above or near the top of the main body of a fire. Vertical ventilation employs a natural process, convection, to evacuate heavy accumulations of superheated air, gases, and smoke up and away from the fire in an action similar to a chimney. As the convection current rises, cooler fresh air rushes in at the base of the fire. Two effects are immediately seen. Smoke is diluted, improving visibility within the structure, and hot air is vented off, cooling the interior of the structure. Vertical ventilation can be accomplished by cutting a hole in a roof or taking advantage of existing openings such as skylights, hatches, and ventilators. Utilizing existing openings may eliminate the need for creating vent holes, provided they are close to the top of the fire. Generally, vertical ventilation should only be accomplished when a fire is involving the upper levels of a structure. The vent hole acting as a chimney will draw the fire to the hole. It may cause unnecessary fire spread and property damage if vertical ventilation will draw the fire through uninvolved areas of the structure. Horizontal ventilation may be an alternative method of venting a fire, especially in lower levels of a multi-story structure. Horizontal ventilation makes use of doors, windows, and even holes chopped in the side of a structure to evacuate combustion products on a horizontal plane. Horizontal ventilation utilizes natural winds and breezes to move combustion products out of a structure. Horizontal ventilation may be the only choice if ventilation is required, but the soundness of the roof is in question. This is especially true when a fire involves a structure with a lightweight type construction. Horizontal ventilation may not be advisable if combustion products may endanger adjacent structures, or if openings will be too far from the exterior of a structure, possibly causing the fire to spread through uninvolved areas. Forced ventilation utilizes mechanical means to accelerate the evacuation of combustion products. Forced ventilation can utilize fans or even water streams to speed up the removal of combustion products. Forced ventilation may be required to evacuate combustion products on a windless day, to vent confined spaces such as basements, or when used in conjunction with ducting to remove combustion products from the interior of a larger structure. Forced ventilation is often employed after a fire has been suppressed to supply fresh air to the interior of a structure, facilitating overhaul and salvage operations. We define ventilation as the carefully planned release of combustion products. The decision to ventilate a fire should not be taken lightly. Liability claims against fire departments are always a possibility. Property owners, unfamiliar with the science of firefighting, may show concern over holes chopped in roofs or floors, broken windows, or forced doors. Improper ventilation procedures can result in intensifying a fire, facilitating fire spread, endangering personnel, causing unnecessary property damage, which can create a poor public image. A fire may intensify as a result of ventilation. Venting a fire increases the flow of oxygen to the fire area, providing a boost to the combustion process. Plans must be made for attacking the fire as the venting process is being completed. Fire spread into uninvolved areas can result from selecting the wrong type of ventilation or improperly venting the fire. Remember, the vent hole will act as a chimney, drawing the fire to the hole. Care should be exercised not to draw the fire through uninvolved areas, spreading the fire unnecessarily. Personnel may be endangered by poor ventilation procedures. Care must be taken not to draw the fire into areas where attack crews may be working, engulfing them in flames. Coordination between the ground and vent crews can reduce this danger and the danger of debris falling on those working inside the structure. Unnecessary property damage can result in two ways. First, by drawing the fire into uninvolved areas, and second, by improper venting techniques causing structural damage which may have been avoided, such as cutting through roof supports unnecessarily, Creating unnecessary property damage could result in creating a poor public image. Creating a poor public image can have all kinds of negative results affecting the morale of the department. While the decision to ventilate must not be taken lightly, it must be made quickly to realize the benefits ventilation offers. The decision to ventilate a fire and the type of ventilation to be employed are based on several factors, including fire involvement, building construction, weather conditions, location of exposures, and the safety of firefighters who will perform the work. The involvement of the structure may determine immediately the necessity for ventilation. For example, a fire burning in a couch will probably not require that a hole be cut in the roof. And a structure fully involved upon arrival has probably vented itself with no need to vent the fire. It's the in-between cases which require further evaluation. And when you remember the benefits offered by ventilation, the release of combustion products which can facilitate entry into the structure and help control fire spread, the need for venting can be further assessed. When a fire is burning at upper levels of a structure or funneling combustion products up through interior stairways, shafts, or voids, or when horizontal ventilation is impractical, vertical ventilation may be required. Vertical ventilation can help clear the interior of combustion products, reduce the danger of encountering backdraft, and help control the spread of flames throughout the structure. Horizontal ventilation may be required if the roof is unsound for vertical ventilation, or if the fire is confined to lower levels of a structure. Forced ventilation may be required when a fire is involved in confined areas such as basements. Forced ventilation can be either in a vertical or horizontal plane. Forced ventilation is commonly performed during the overhaul stage after the fire has been suppressed, even if other types of ventilation were not performed. Building construction must be considered when deciding to ventilate. Roofs can be flat, steeply pitched, or anywhere in between. Roofs can be made of concrete, metal, or wood. Shake roofs are extremely slippery when wet. Tile roofs can be equally treacherous and may crumble underfoot, causing unnecessary property damage. Beneath the roof there may be nothing at all, or a cluttered attic space. In some cases, holes may not be required to vent a roof. Many newer homes and commercial buildings have installed skylights, which may be removed to vent the fire. Fiberglass melt-out panels are often incorporated in the roofs of commercial buildings and warehouses. Special roof vents with fusible links pop open when the solder link melts to automatically vent some commercial buildings. Other buildings may have sheet metal roofs, which can make it possible to pry up an entire sheet, providing a vent hole. And it may be possible to locate a plywood sheet on some roofs, which can be pried up rather than attempting to cut through the plywood with an axe. Walls can be made of concrete, metal, wood, or even glass. And who knows what you'll find behind some walls or doors. Familiarization with structures in your protection area can prevent sudden surprises. Fire pre-planning may possibly answer the question, what if we had to ventilate this roof? Here's an example of a roof which would be impossible to vent without the use of an aerial ladder. Here's an example of a roof which may be impossible to ventilate through conventional means. And maybe the best way to vent this building would be by pulling the cork. The weather is important when considering venting. Wind direction and speed are very important. Vertical ventilation should be as high on the roof as possible on the downwind side of the structure. Placing the hole on the downwind side of the roof allows the wind to pull combustion products up and away from the structure. If the vent hole were to be placed on the upwind side of the structure, the wind could very possibly blow down through the vent hole, spreading flames throughout the structure and endangering personnel who may be working inside. If horizontal ventilation is elected, the downwind opening should be made first, immediately releasing combustion products. Then the upwind hole can be completed, providing a flow of fresh air through the area. If the upwind hole were completed and something went wrong with the completion of the downwind hole, the results could be disastrous. The wind entering the upwind hole could blow fire throughout the structure. When electing to vent horizontally, care must be exercised not to endanger exposures with direct flame contact or radiation. Location of exposures must be considered not only when venting horizontally, but also vertically. Released combustion products may carry firebrands and cinders up and out through the vent hole, which could travel some distance, involving other structures. The safety of personnel is very important. Ventilation should not be started until a dependable water supply has been established and attack lines are being placed. Ventilation crews should have a charged hand line available to them for additional protection. The fire will intensify with the fresh air supplied through ventilation. You could have a real problem on your hands if the fire is vented without being prepared to attack it. Full protective clothing is a must, including self-contained breathing apparatus. Venting, especially vertical venting, draws the accumulated combustion products right to the area where you're working. Operational hazards such as power lines, telephone lines, antenna guy wires, or other obstructions should be considered and avoided when possible. Ventilation crews should have alternative escape routes planned in advance and, if possible, be in radio contact with the ground. Ladders should be placed away from windows where possible outbreak of the fire could cut off the vent crew from the ground. Ladders should be heeled or secured to a substantial support to prevent accidents while personnel, tools, and equipment are being ferried to the roof. The top of the ladder should extend at least 3 rungs above the roof line. This extension serves as a support for personnel stepping onto the roof. The first person up to the roof should carefully evaluate the condition of the roof. One sign of weakness can be a saggy appearance, which may indicate supports have been weakened. Signs of fire advancement to the spaces under the roof include bubbling tar or roofing material, even the presence of steam on a wet roof. Smoke puffing out from under roofing material is not a reliable indicator of danger due to the construction of some roofs which allow attic spaces to breathe. If the initial evaluation indicates it is safe to proceed, a roof ladder should be placed with hooks extended over the peak of the roof. The roof ladder will provide positive footing, especially on steep roofs, distribute the weight of personnel, and provide a safe work platform from which to complete the vent hole. Even on a flat roof, roof ladders can offer the same benefits: provide positive footing, distribute the weight of personnel, and provide a safe work platform. In the event of roof collapse, the roof ladder may be the difference between losing or saving the ventilation crew. Working from the roof ladder, soundings should be made to test the safety of the roof. By thumping the axe at various places, firmness of the roof will let you know whether or not it's safe to continue with the venting process. Sounding will also indicate the location of rafters, so you can mark out locations for the vent hole. If manpower permits, a minimum of 2 firefighters should be committed to the venting process. Venting is strenuous, especially with full protective equipment on. A charged hand line will offer crew protection in the event of flame encroachment on their position. While one firefighter is working, the second should man the hand line, watch for danger, and keep in communication with command. In this example, the advantages of a 3-person crew can be seen. As one firefighter works on the vent hole, the second is supporting his back to prevent loss of balance, while the third firefighter is manning the hand line, acting as safety lookout, and keeping in contact with the ground. The use of safety lines, particularly on steeply pitched roofs, can provide an extra margin of safety. Even out on a flat roof, safety lines can add that extra margin of safety, especially in the event of a partial or complete collapse. We've defined ventilation, explained the need for ventilation, described the types of ventilation, and explained many of the factors to be considered if ventilation is necessary. We will now demonstrate the basic principles of vertical ventilation and horizontal ventilation. While power tools may be used to vent a roof, We will demonstrate the basic principles of venting using an axe. Vertical ventilation is accomplished by placing a hole high on the roof close to the main body of the fire. This creates a chimney effect which will allow convection to lift accumulations of combustion products up and away from the fire. Once ladders are positioned, the roof is sounded for firmness. Weakened roofs will feel spongy or saggy. Venting should be abandoned if the safety of personnel is in question. Sounding will also locate rafters, which may run up to a central ridge board. Many newer homes constructed with prefabricated rafters may not have the central ridge board. The sheets of plywood, decking, or slats hold the rafters in position. One vent hole is preferred over many. Generally, on an average residence, the vent should be at least 4 feet square. With rafters set on 24-inch centers, locating 2 rafters yields the width of the hole. Roof repair will be facilitated by not damaging rafters. The pick end of the axe can be used to strip away shingles or roofing material, which will expose plywood sheeting, slats, or decking. 3 cuts will be made with the axe. 2 cuts parallel to the rafters, the 3rd cut across the top dimension. Loosened material can then be pried out, finishing the hole. The first cut is made parallel to the rafter furthest from the ladder, beginning at the top of the roof, working down. Using short strokes rather than while swinging will help control the cut and help you maintain your balance. Cut along the length of the rafter as close to the rafter as possible. This will help reduce axe bounce as the material is being supported by the rafter. Cut at an angle in toward the center of the hole. Alternate chops can be used to clear the cut. When the first dimension, furthest from the ladder, is completed, return to the top of the hole and cut across the top dimension, working back toward the ladder. Always working back toward the ladder provides maximum security should your position become precarious. Avoid cutting into rafters while completing the top dimension. The 3rd cut is made close to the ladder, cutting from the top of the hole downward. By now, you may be encountering dense smoke and the value of wearing self-contained breathing apparatus appreciated. Team members should be watching out for flame breakthrough with the charged hand line ready to provide crew protection. The effects of venting will be rapidly apparent. The technique used in creating the hole, making the first cut along the rafter furthest from the ladder, cutting the top dimension, and clearing with the 3rd cut, permits venting to begin and allows the crew to abandon the hole if danger to them becomes too great. The final step in venting a roof is the opening of the ceiling below. Use a pike pole to create a ceiling hole at least as large as the roof vent hole. Long, narrow buildings which share a common roof and attic space can be vented through a technique called trenching. Trenching involves removing the roofing between at least 2 rafters all the way across the roof from side to side. Trench cuts can be successfully used to stop the spread of fire through long, narrow structures which share a common attic and roof. From time to time, it may be desirable to cut a vertical vent hole through a floor. The same principles apply as when venting a roof. Take soundings to locate floor joists. Remember that downwind openings should be completed first to provide an immediate escape of combustion products. Then the upwind opening can be completed, providing a flow of air through the structure. Make use of existing doors or windows if at all possible to complete the venting process. Doors and windows can be utilized in combination with each other depending upon the location of the fire. Quickly check doors and windows to see if they are unlocked before damaging them. Windows can be removed with an axe, or if up high, a pike pole. Remove upper panes first, where the greatest density of combustion products has been accumulating. Full protective clothing can prevent cuts from flying glass. Decorative woodwork, blinds, and curtains should be removed to provide a smooth flow of air and clear shards of glass from the entire window frame. Once the downwind opening is completed, the upwind windows or doors can be opened, providing a flow of air through the structure. One problem you may encounter is the use of plastics instead of glass as windows. Certain plastics, such as Lexan, are extremely strong and can't be smacked out with an axe. These plastics may be found in schools and businesses where glass breakage has been a problem. Forced ventilation can be utilized to speed up the venting process, provide ventilation where there is little or no wind, or to ventilate confined spaces such as basements. Forced ventilation makes use of fans or even water streams to pull and eject combustion products from a structure. Forced ventilation may be utilized during overhaul and salvage, even if ventilation was not actually performed in controlling and suppressing the fire, to clear the atmosphere of combustion products. Ventilation is just one of the many specialized techniques available to you for the control and suppression of fire. Ventilation is the carefully planned release of combustion products into the atmosphere. Properly planned and executed, ventilation offers several important benefits when dealing with a structural fire, including the release of accumulated dangerous combustion products, reduction of danger to firefighters who may have to enter a structure for search and rescue of potential victims and for fire suppression, and can be of assistance in controlling a fire. The decision to ventilate a fire should not be taken lightly, but should be evaluated quickly to realize the benefits offered by either vertical, horizontal, or forced ventilation. Among the factors to be considered before committing a ventilation crew is the involvement of the structure, building construction, weather conditions, location of exposures, and the safety of personnel not only committed to the venting, but also working within the structure. Personnel should not be committed to an unsafe roof. Alternate escape routes should be planned in advance. Full protective clothing should be worn, including self-contained breathing apparatus. Roof ladders should be considered to provide positive footing, distribute the weight of personnel, provide a safe work platform, and possible escape route in the event of a roof collapse. And communication should be maintained between the roof and the ground. Improperly planned and executed, ventilation can intensify a fire, facilitate fire spread, endanger personnel, and cause unnecessary property damage, which can result in creating a poor public image. Correctly planned and executed, ventilation can be an effective weapon in combating a fire. But remember, the risks involved are considerable.